Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we'd have a look at this. Now what we've got here is my current limiting bench power supply. I've had this for quite a few years. I bought it off a radio amateur years and years ago, and I used to use it all the time. Unfortunately it packed up a while back and it's literally just been sat on in the corner of my workbench. And I've got a project on at the moment where I'm playing with some old 1970s op amps, and they need a split rail supply to run them. You basically need 18 volts positive and 18 volts negative, and the little power supply I normally use while I'm messing about with breadboard on the bench is just a straight linear supply. You know, it gives 0 to 25 volts at 500 milliamps, and it's fine for a lot of projects and just running things up on the bench, but I really need this thing back in service. So what I thought we'd do in this video is crack into it and see if we can find out what's gone wrong with it and see if we can get it going again. So it is a very nice unit, this. It's dual voltage, 0 to 30 volts at 2 amps. So you can dial that up to 18 volts, connect it up one way up, so you've got your plus 18 volt supply, connect that one up to 18 volts, connect it the other way around, so you've got a minus 18 volt supply. You can current limit them down to, you know, 100 milliamps if you want to. So again, it's handy. You know, if you was working on some old 48k Spectrums, and you know when you have an issue in the power supplies and then it can do all sorts of damage, you can set like a 800 milliamp, 900 milliamp current limit on here, and if the something goes wrong with the Spectrum, instead of blowing the transistors up, your current limit will just cut out on the power supply. So it's a very useful, nice piece of kit. It's just we need to find out what's gone wrong with it. In fact, we'll plug it in and switch on, and we'll see what it's actually doing at the moment. That's on, that's off, that's on. Now, as you can see, it's got a coarsener fine. We've turned it. That should be displaying set to volts like that. When you turn the basically when you turn the controls up, it should be showing a voltage on there, and we should be able to measure the output on there. As you can see, it's not doing anything. That's current measurement, so switch it over like that and it'll measure your current what's being consumed through the circuit. But as you can see, it seems to be absolutely dead. It's not showing on either meter. It's not showing any voltage at all. What we can do is we can connect the meter up to it. I've got my my digital multimeter set up here, and we can see if it could be just a meter fault, and we could actually have an output from here. So we'll connect the meter up and we'll set that onto voltage, we'll set it to DC, we'll set it onto the 100 volts range, and we'll connect up this will make it a bit difficult to adjust the scales, but we'll connect up like that. We'll try turning up, and if we look up there on the on my meter, I've turned that right up on so that should be showing 30 volts on there, and as you can see, there's absolutely nothing showing at all, so it's not producing any output whatsoever. We'll bring you back down onto it, switch off, and just get them out of the way. Let's switch it off and unplug it, and we'll get the case off, and we'll have a look inside, see what we can find. Now I think these things use big power transistors to regulate the voltage, to get your output voltage, so we could have some blown output transistors in it, although why both sides are affected I don't know. You'd expect that just to affect one side. I'm hoping it's not the mains transformer that's developed a fault. But again, you'd expect them to be separate windings for each side because they're meant to be completely isolated. It's weird that both sides are being affected. I can't remember whether one side failed then the other side failed, or whether they both failed at the same time, unfortunately. I think we do have to take that one off as yeah. Well, don't even make it easier getting in these things. Plenty of screws, but they are well built. They are, you know, you don't get anything built like this nowadays. This unit's probably what? It's probably as old as I am. It was probably like me, made in the 70s. Right, there we are, we're in, and wow. That is a serious piece of kit. It's basically, I don't know if you can see this, but we've basically got two separate power supplies in one unit. That's seems to be what we've got. We've got two banks of smoothing capacitors. We've got two control boards, two sets of bridge rectifiers, and we've got two mains transformers down there as well. Yeah, we've got two mains transformers in there. So why the bloody hell is both sides gone dead? This could be either a really, really hard fix or a really, really easy fix. Let's have a look on the back. Just look at that 70s goodness there. And what have we got? It's like almost military spec the way this thing's built. I've seen like this kind of building old military equipment that I've pulled apart. We've got two fuses on the back, 2 amp fuses on the outputs. I'm going to kick myself if oh, we've got our 2 blown fuses. I really am. It can't be that simple. We've got the fuses out. There we go, we've got 2 fuses. Let's get that meter set to the ohms range. It's not going to be this simple. No, that fuse is good. Let's try this one. And that fuse is good. Put them back in. There we go. Make sure they're well tightened in. And we've got, this is what I was saying about power transistors. We'll just take this panel off the back and I can show you what I mean. In fact, we'll need a bigger screwdriver for them, I think. As you can see, we've got great big banks of, just get that out of the way. We've got great big banks of power transistors on the back here. And they're actually double stacked, I think. I think basically you've got 2 banks, so you've got 1, 2, and then behind that there's 3, 4. And then we've got again 1, 2, and behind that we've got 3, 4. So we've got 8, I presume they're NPN, PNP push-pull pairs, like you'd find in an audio power amplifier. So that could be the issue. We could have blown output transistors, which would be a bit of a pain, because they might be quite tricky to get nowadays. Or at least something that's suitable might be quite tricky to get to replace them with. I wonder if we power it up like this and we take some voltage measurements. Basically, I'm just interested to see what we've got coming in at the bridge there. Oh, sorry, let me get you up so you can see what I'm pointing at. Basically, I'm interested to see what we've got coming up at the bridge here, because we've got we'll work, because it does look like basically we've got 2 entirely independent power supplies here, separate mains transformers, separate everything. We'll work on one side, we'll try and get one side working, and then we can swap over and have a look at working on the other side. I have noticed straight away that that capacitor there does not look happy. Let me see if I can find my proddy thing. Not that proddy thing, my other proddy thing. Where's my other proddy thing? There it is. That capacitor there, although it's not gone hard, it's very oxidised around that side there. It doesn't look happy. So it could be that we've got some problems on these. It's like a driver board basically. This is what via the pots on the front, this is what basically controls the power transistors on the back, which is what gives you your output voltage. That's your main. There's your main bridge rectifier to give you, I presume that'll give you about 30 volts or so out. And so then that goes into the power transistors. That there, using the pots on the front, is what will give you your current limit and give you your actual adjustable output voltage. So it's a case of finding out where the fault is. So I think we're going to power it up and we're going to see what voltage we can find where. I will see if I can dig a circuit diagram out for this thing as well. I think this is going to be part 1 of part 2. Most definitely. What I will do is we'll have a bit of a poke around now, and then I will finish this video. I'll go away, I'll see if I can dig out some service data for this thing, because obviously we've got a bit more of a complex fault than I was initially thinking we would. Anyway, let's power up. We've got that switched on. No, we haven't. It helps you get it switched on. Right, power up. And now we've got nothing there. But we'll see what. We'll see if we've got anything. In fact, we might be able to use the ground connection on the front of here to ground the test meter out. And we can go and have a look for some voltages. We'll set that to volts DC. Yeah. And we'll have a look, see what we've got about on the board, see if we're actually getting anything on the board. Like that capacitor there, we know it's a 63 volt rated cap, so we'll go on the positive side of that cap. We can see we've got some voltage there. And we are getting absolutely nothing. I wonder if we're getting anything off the bridge rectifier. Now, which side go? The question is, see, this is so well loomed. It's really hard to trace wiring on it as well. We can tap round on the bridge. Obviously, some of these connections are going to be AC and some are going to be DC. So we can have a tap round on the bridge, see if we can see anything coming out of here. There's nothing there. Nothing there. Nothing there. nothing there. Now I think them two purple wires there are the AC connections. So you've got a blue and a brown, and then you've got two purple ones. So I'm suspecting that the two purple ones are going to be our AC connections into the bridge rectifier, and the blue and the brown are going to be our output. So I'm going to set the meter to the AC range. We'll take it off there, off the front, and we're going to go across between that wire there, that terminal there, and this other purple one here, and we'll see if we get an AC voltage on the test meter. I've got the meter set to 100 volts, which should be absolutely fine. We're set to AC voltage on it as well. So one on there, and that is showing absolutely nothing coming out. Just to make sure we're now between that one and that one, I'm getting there's nothing there. I'm getting 0.5. That's just an erroneous measurement, I think. I don't think that actually is any. It's telling me I'm getting 1.5 volts AC between them two connections there. I expect it's between them, but no, there's nothing there at all. Let's try on the other side, see if we've got anything similar on the other side. I'll just switch the power switch off while I turn it round. I'm being very careful obviously with my fingers. I don't want to get my fingers in anything that's live in here while we work on it. We'll switch back on. So that's energised. And again, we'll try between the blue and the brown. This is still set to AC, remember. Right, there I'm getting 15 volts there. Getting 15 volts AC between that brown wire and that blue wire. Now, are we getting any AC between them two purple wires? Because they're the wires I'd expect to see AC through, but no. So it looks like the AC is on the blue and the brown. So does that mean that we've got DC on the other two? It should mean we've got DC on the other two. So let's switch across to DC. And we're getting absolutely nothing there. Try it the other way around. Nope, absolutely nothing. So let's switch off again. Have we got some bad diodes? Could our diodes have gone bad? It won't explain. Could the diodes have gone bad and blown one of the transformers out? I mean, that's going to be a real disaster, because I don't know where I'd get a transformer for this thing. I'd probably have to have it rewound, which would probably be more than the unit's worth, to be fair. Let's set this to do a diode check. No, I'll try it the other way around. It's rather tricky to do a diode check with the diodes actually in circuit, but these, I might actually use my other meter for doing this. Because that's coming up with it, all the diodes are shorted. But that could be, it could be that the because it's in circuit, it's not always a good idea to test the diode in circuit, because it can give a bit of erroneous reading. We'll try this. It's a cheap Chinese tester, but it should be able to read it as a diode if it is at least working as a diode. Let's try it. Nope, I can't read that as a diode. Let's try that one. That says there's 2 diodes in parallel, so that looks like that might be working. What we should really do is disconnect the wires to this and then test the diodes. That's not coming up as a diode. Try this one. It's not a perfect see, they're not coming, only one of them is actually showing up as a diode doing that test. So have we got a batch of bad diodes? We certainly could have. We could also have some bad caps here, like that cap there. They're not the most reliable of capacitors then. So that could have failed, that could be causing us problems, and that's right across, by the look of it, those 2 purple wires there. At least if that is how it's so tightly loomed together. Like I say, it's very, very hard to follow anything in this thing. That's why I think I really need to go and print the circuit diagram out for it. Is that, yeah, that board's the same board as over there, but that one seems to be upside down. I think that's how it is. So we've got a capacitor down there pointing that way, and that capacitor up there in that corner. I think if we turn it round, yeah, it's exactly the same board, it's just upside down. So that's that capacitor there, is that red one that was up there, and that's that capacitor that was down there. So that's slightly odd. It's kind of upside down and back to front, one side to the other, but it is basically just 2 power supplies in one box. It's just a bit bizarre that they both decided to fail at the same time. I wonder if we get anything different if we try doing a quick diode test on this side. Let's do this quickly and then I will finish this video, get it uploaded and go online and see if I can find a that's not coming up as a diode. Like I say, it could be because it's wired up. Well, the next thing obviously we'll do is disconnect these bridges and test them properly. It's showing very much like the other one did, this. Yeah. Yeah, I mean, on the other one, at least one of them did show up as a diode. None of them have on that side. So we could have a problem with the diodes there, but we won't know for that for certain until we can disconnect the wiring to it and actually test them diodes properly. Should we do that as a... I was saying, no, we'll do that on the next part, because I will get a circuit diagram for the thing first. So I'm going to leave it there for now. I hope you enjoyed this little part 1 of this power supply repair. So I'll say thanks for watching and goodbye.